You can also find all of our webinar recordings on the Evolve YouTube channel. We'll have some time for Q&A at the end, so please submit your questions using the Q&A function in your Zoom toolbar. Great. And we'll also be running some polls today, so keep an eye out from that. We'd love to hear from you guys. All right, Ross, you want to get us started?
Yeah, absolutely. Thanks, Marina. And thanks for joining me today, Jason. Really excited to be talking about this topic because I think it's something, after watching a lot of the Evolve webinars, that we don't talk about enough, and that is how we do documentation of existing buildings. There's a lot of emphasis sometimes on using Revit and using Evolve plugins and things like that on new construction, but there are certainly some unique challenges that come along with documenting existing buildings and some unique technologies that have been developed to make that a little bit easier. And I think that that will be something that will be very insightful and hopefully relatable to everybody here today. And as Marina mentioned, we do have some polls throughout. And so please, it would really help if you would weigh in with your opinion as we go throughout the presentation here, so we can make sure that we're kind of honing in on your needs. I guess real quick, I'll introduce myself, and then Jason, if you want to introduce yourself. My name is Ross Younger. I'm with BIM Technology Management, but prior to working with BIMTM, I was also working in the reality capture space, which is something we will be talking a lot about today, working in historic preservation. It's an area where you are using things like laser scanners and drones and other innovative technologies to document existing spaces. And that's something that I think is very applicable to what we'll be discussing here. Jason?
Hi, everybody. Thanks, Ross. My name is Jason Earl. I'm a product manager for the Revit products here at Evolve. My background is primarily in electrical construction, working in the field and working in VDC. I've also worked on multiple projects where we used a laser scanner to help us accomplish a few different things to create the deliverables that we needed for those projects.
Awesome. Thanks, Jason. So this is, if you are aware, a part of a series that we've been working on with Evolve and BIMTM, and we are trying to set the bar high to really get standards and get individuals up to speed. That's really what we're all about, is trying to be a resource that can make BIM work for you. And Evolve has been a great partner as far as that goes. So that's what we are all about. Right off the bat, I want to ask our first question, which is, how frequently have you had to design around pre-existing building infrastructure? And Marina, you can go ahead and toss that up. The answers here then are frequently, occasionally, very rarely, or never. So again, how frequently have you had to design around pre-existing building conditions?
While those results come in, just kind of speaking from my experience, that was our something that we had to do pretty commonly when I was with a contractor. Our bread and butter was really core and shell, but we really kind of, we would do everything. So if it was kind of working with MARTA, so train authority, working in those sorts of conditions, or especially kind of working in high-rise offices where we were, developing out a space. So that is one of those cases where laser scanning would come in very useful.
Oh, absolutely. And I'm sure we can get more into that as we go through here today. But early results are in. Looks like we have a lot of folks that have worked with existing infrastructure frequently, or at least occasionally. Jason, are you surprised, or is that kind of what you were anticipating?
I think that would probably match up with my expectations. I think most of us would love to only ever work with new buildings and new construction. However, there are a ton of existing buildings, and it's kind of the nature of the game.
Yep, absolutely. Absolutely. And, it is something that I know that the AAA published a recent study, and this might be a post-COVID effect, but for the first time in as long as they've been doing the survey, 52% of construction jobs were going to be in reconstruction in the year 2024, as opposed to new construction. And so reconstruction is taking a more and more prominent role. So it's something that I'm glad we're talking about today. All right, we can close. I can close that. All right. So I want to talk about the challenges real quickly of working in the built environment, because that is why we're all here today. And I've always heard that you want to start with the why. And so here are some of the challenges. And then Jason, I think that you probably have some more hands-on experience, but these are some of the challenges that you will encounter working in the built environment. Certainly with everything installed, there's limited space. You have outdated and obsolete infrastructure, which can also go with different code considerations. There's also occupants to deal with, which can certainly be a challenge. I did a laser scan of a senior living facility, and occupant disruption. I don't think it was a problem for them, but it took a little bit longer than expected because you got a lot of life stories and things like that. So you certainly need to take into account who you're working around. Also accessibility. You have a lot of concealed spaces. You're going to have to operate above ceilings where there's drop ceiling tiles and things like that. You have finished walls. And then what we'll be really getting into is missing or incomplete documentation. Jason, any of those in particular that are kind of a sticking point for you?
Yeah, definitely. In the subcontractor space, when we did have to work in existing buildings, what we found was, the older the building, the more missing and incomplete the documentation is. You'll get drawings, but sometimes a door isn't where it used to be, or walls have moved. And then especially, any, because I come from the electrical side, whenever we have to do kind of any sort of big maintenance or new installation, it usually involves a shutdown, whether it's shutting down the whole building or shutting down an important piece of equipment. And that can really, really throw an issue in things where things kind of take a lot longer than you would like, and having those buildings shut down longer than is absolutely necessary.
Sure. And I think that that's really hitting at why we're having this conversation today, because there is disruption involved. I think it's something that there's more of a sense of urgency when you're working in these spaces to get through the process as quickly as possible. And so specifically, the faster that you can document, the better. But fast documentation, depending on your method, can also mean you're more prone to errors. And so trying to strike a nice balance with some of the new documentation methods. So along those lines, question 2, audience, what is your top consideration in MEP design modifications for existing buildings? Is it minimizing disruptions and downtime? Are you most concerned with complying with regulations? Are you looking at adhering to your budget constraints? Or does it really all come down to the overall project timeline? And Maureen, I'm sure somebody said this before, but I almost feel like we should have a Jeopardy, Jeopardy track on the side here.
Yeah, I know. Kind of speaking from my experience again, our biggest worry really is minimizing disruptions and downtime. Customers never happy about having to shut down equipment, so that was really the biggest for us.
Absolutely. Ooh, a much more even distribution here. Almost evenly split. Couldn't have asked for a better result. Jason, what are your thoughts?
Yeah, I think that's probably not too surprising. Kind of with any project you go with, there's a lot of constraints that you have to fit under. So it's no surprise that there's a bunch here kind of vying for the top spot.
Yeah, and then also with regulations, something that I personally am not dealing with on a regular basis, but all of a sudden you're working in a system that might be out of code, and you are looking to be as compatible as possible with that. And there's a point where something that might have been kind of grandfathered in is affecting you directly. So I could see where that could be an issue as well. But of course, achieving product timelines goes right along with minimizing disruptions. And so I'm just going to group those together and say, yeah, that's 50% of our pie there, and I think that is something that we're looking to address today. Right. So, real quickly, we want to cover how we got here. This is a slide that was originally going to be with another panelist that could not join us today due to a family situation, a very happy family situation. And I'm glad that he provided some slides and some context. I think without it, my timeline would have been, cavemen, math, and then BIM, and then evolve, essentially. And so he's really able to, provide some of that context. And Jason, to your point, I think that this will illustrate why there are issues with finding documentation or being confident in the reliability of that documentation. So, brief story of documentation. Really, from buildings, it really had widespread adoption during the Great Depression era as part of the big deal or the New Deal. There was a pilot program where people went out and systematically documented buildings and historic sites. And then once that was completed, that was something that was much more widely adopted, certainly in new construction. So you can see folks here, and that actually looks very close to a BIMTM standard uniform. The hat hasn't been adopted, but you can see folks out here documenting some existing spaces. And this is something that you would have eventually gotten their HABs drawings, something that is important for historic preservation, something that's maintained by the Library of Congress, at least for existing buildings. And often that will be primarily consisting of elevation views, floor plans, and if there's something notable, certainly there could be some schematic designs involved, but it's really more about the architectural documentation. Having said that, there is something to be said about when systems were being introduced to buildings. That's something that's really interesting about working in the built environment. Now looking back, it's something that all of these are standard, but there was a time when you didn't have necessarily fire protection, or with plumbing, we were joking that early plumbing, you were lucky if you had a faucet, maybe a toilet, but not much of that. So looking at the timing here, really in the 1820s is when you started to have some standard fire protection, more in mills and manufacturing environments, and the adoption of more widespread going into the turn of the century was really driven by insurance companies for plumbing. There are certainly toilets and things like that that were being schematic, but it was the turn of the 1900s where it became common for new construction. But even then, you're looking at very, very basic documentation. A lot of things are hand-drawn. Sometimes things will literally be on a napkin, which is not ideal and not something you want to hang your hat on. And what we have here, this is an example of one of the historic locations in West Bend, Wisconsin. It's a former jailhouse, which is now a museum. Really interesting because there was actually a front area where the warden lived and then all the cells in the back. But in the basement here, you can see that, and Jason, you can maybe interpret better than I can, but this is, some very rudimentary, plumbing schematics here, which basically just show, hey, this is where they're going to go. Without, not much that you can really work clash detection off of.
No, absolutely. Still better than nothing, right? Coming back,
Yep.
digging for something new, you kind of have a general area of when to switch over from the heavy equipment down to a shovel. So I think a lot of this kind of really illustrates really well like why documentation is so important, right? As our buildings and our building methods have become, more complex and we're building larger buildings, it really kind of shows and highlights that need for documentation, right? Because a building is really a living thing, right? It sticks around with us for, an ideal world over 100 years. So it's going to change during that period. And documentation can save a lot of headaches down the road.
Yeah, yeah, absolutely. And I guess that's something too that folks working in this space were really participating in that. By providing that accurate documentation, we're making it so the long-term life of this building is going to be even more efficient. It might be able to last longer, and so we keep a lot of our character and things like that in these historic buildings. So it is very important. This is a structure that largely is originally intact, but then also you get into situations where buildings have multiple additions and they have reconfigurations and they blown out walls, and to have a single set of documentation is sometimes rare. And talking with Steve, our other speaker and friend, he was talking about how often you will end up having to go really to any resource you can. There's not really a central repository of this type of documentation. You might go down to the courthouse or down to look at tax records. A lot of times you're digging through boxes in the basement. And so, again, that's something that if you're lucky, you will get some type of designs. But from a schematic design standpoint, that can be even more rare. Now getting into, again, electrical and HVAC, it's something that was adopted earlier in the 1900s, a little bit later in the process here. An interesting anecdote was that early conduit was just carved out wood that they would run wires through. So again, not really the highest consideration for. I don't think that would meet code today. I'm not a code expert, but I think
yeah, last time I checked, no, it would not.
yeah, and also it also goes along with the fire protection. It seems like there might be a little bit of a fire hazard there. But also, I mean, that's really interesting too. And I think that that's something that we don't touch on specifically, but when you're looking at working in existing buildings, you're also often having to work with some very, very old and outdated systems that are still operating the building today. I know that I had a very scary experience in college. I thought it would be a great idea to replace a ceiling fan and open it up, and there was no, shouldn't there be a red wire, and shouldn't there be some labeling here, and you're not dealing with that, and so certainly that can be an added challenge. And then again, going into HVAC, that was something that was really populated areas first, more densely populated areas that became standard, and then it became something that was a little bit more widely adopted in all building design. And also something that's interesting, what I hear is that the first air-conditioned building in the United States, or the first air-conditioned theater, is in Milwaukee, Wisconsin. It's the Pabst Theater, and it was constructed at the turn of the century, replacing an old building, but they cooled this building by putting giant blocks of ice above the ceiling and then blowing fans into the building. So hopefully we're a little bit more efficient today. All right, so with that history, what tools do you rely on the most for MEP assessments in existing structures? Marina, if you want to pop that up. And your answers here are existing drawings, the old school traditional field measurements, some new methods like thermal imaging, or 3D laser scanning. Jason, any horror stories about going out there with a tape measure?
Well, luckily for us, for the most part, that's what the engineers would have to do before we got drawings as the subcontractor. But yeah, I mean, before we started laser scanning, you would go out there with a tape measure and you'd kind of make a rough drawing. And really, for the most part, you would just kind of go in and do the work that you needed to do, right? When we have that documentation, it opens up kind of new avenues that we'll talk about probably here in a little bit.
Mm-hmm.
But without it, it kind of just bring the materials in and get to work and fit in where you can.
Sure, absolutely. All right, so yeah, it looks like there is a good mix between existing drawings when you have them, and then 3D laser scanning, which is something which is a great segue into what we're going to be discussing today, which is how we're using that tool and how the industry is using that tool. So the technology, the primary technology that's being used right now is 3D laser scanning. So 3D laser scanning, also referred to as LiDAR, which is light distance and ranging, basically covers the entirety of a subject with individual point measurements, each of which represents an XYZ coordinate. So, think of a laser measure. You point that out, it extends until it hits an object, and then it reflects back and gives you that distance. That would be one point in a point cloud. And now imagine that essentially what's happening with a laser scanner is that it's methodically rotating and getting about 1 million points per second to document the entirety of a space. And these millions and millions of points, when combined, really can provide the overall shape and geometry of different objects, and also dealing with something that is in the built environment, especially with very aging buildings. It's a zero contact, non-invasive method of documentation, which is very useful. And then looking at scanning, essentially what you also need to realize is that although each scan produces a point cloud, you, in almost all cases, need to do a large number of scans and combine them into what we would call a registered point cloud. And you do that by making sure that there's sufficient overlap between the different points, and then tying those together in the registration process. And then you get what is called a registered point cloud. There's a variety of softwares you can use to do that, but there is one with the Autodesk AEC suite, Autodesk Recap, that can both do registrations and then also provide you kind of a virtual tour type environment that you can navigate your point cloud, and then also take real-time measurements. And so one of the big selling points is that, from what I've heard and what I've seen, no matter how many measurements you get, you never seem to get every measurement you need. There always is a need to go back and get additional measurements with traditional methods, and especially going back to looking at the disruption that can happen with existing buildings. That's something you want to avoid. And so that is something that with a laser scan, you get every measurement as long as there's not obstructions, and depending on the density kind of those scans. But it means that you don't have to go back. You have every documentation at your fingertip, which is why that would be commonly referred to as a digital twin. All right, so laser scans. How often, audience, have you utilized 3D laser scanning as an MEP design tool? Have you used it frequently? A few times? Once? Never, but there's certainly situations where I could have used it, or never, not for me. And I guess, Jason, what's your take on folks that are using laser scan for the first time? I think that's one of the concerns is, the usability, and how accessible it is.
Yeah. I mean, for me, it was quite accessible. I mean, they're pretty simple, to be honest, nowadays. Really, you kind of just turn it on, and there's some settings you can change for how many points you're capturing, and ultimately it just affects how long the capture takes. But it's really, you turn it on, you set it on the tripod, and you hit go, and then you have a scan. Kind of the first and most important thing that I learned was you can definitely get by with having too many scans, but you can't get by with having too few. So starting out, especially, take more scans than you think you need, because you're going to end up needing them.
Yeah, and I think that's specifically when you're working in some of the tougher environments. If you're documenting above a drop ceiling, for instance, it's something where you're probably extending that laser scanner up to its max height potential, and there might be some sway and things like that. And so, you know, in the post processing, there certainly is occasions where you'll need to discard a few scans as well. And so, the more coverage you have, certainly the better.
Absolutely.
All right, and I will mention the one step that you missed is run and hide. If you don't want to be in the laser scan, it captures everything. So certainly something that you need to look at. But the survey results here, how often have you used laser scanning? And it sounds like it is something that's getting out there and being a little more widely adopted, either frequently or a few times. Folks have used it in the past, and so yeah, it really is a great tool, and certainly, you know, something that I hope to hear a little bit maybe more about in the Q&A. Jason, again, right in line with your expectations, especially with the number of folks that we have that have worked in the existing building environment.
Actually, it's kind of surprising.
Okay.
I wasn't expecting to see this many people having used 3D scanning before. I know, you know, the company that I worked with was a pretty large contractor here in Georgia, and you know, they made it seem like when they purchased that scanner that it was like, you know, they bought some unimaginably expensive thing, and it was expensive. But it sounds to me like, you know, prices have continued to decrease for laser scanners, making them more available. So it's really encouraging to see more people using it because it is such a great tool.
Yeah, absolutely. I think that they have become more affordable, and also, you know, there are more and more service providers out there of that as a service, and so something that, you know, you don't necessarily need to invest in the, you know, what used to be $40,000 to $80,000 equipment. Now there are scanners more in the $20,000 range, but that's something that, especially if you want to dabble with it a little bit, you know, there are a number of resources available. You know, networks available, and that's also something you could reach out to BIMTM about, and we could see if we could tap into that network for you if you're looking for a provider. So moving right along, this is where we get into scan to BIM. Jason, tell us about scan to BIM.
Okay, so scan to BIM, in my words, would be, you know, we have an existing building or an existing object that we want to scan, but you know, the whole point of scanning it is so that we can work with it really in Revit. Now I'm sure there are other softwares where you can work with point clouds, but from my experience, that really revolved around Revit. And where we found the most use out of that, you know, we could have taken measurements, we could have kind of built walls, or in this case, you know, there's a roof here. This is a point cloud of a parking deck. We could have placed some columns, you know, with measurements. But the scan is so much faster and so much easier. In this kind of case here that I've mocked up, this is, say if we were going to add EV charging stations into a parking deck. The point cloud that I created this from was only one scan. Ideally, you'd probably want to end up getting a few more. But you know, the scans, when I was scanning the fidelity or the density of points that we needed, you know, we could get away with 2-minute scans. So we could scan a large area very, very quickly. And so in here, what I've done is I've shown in Revit, we took a point cloud and we modeled up these EV charging stations. We modeled the conduit that's going to go back to some equipment that's going to feed these. And the real advantage of scan to BIM, in my mind, is twofold, and part of it kind of depends on who it is. But from the contractor's perspective, it's really about that interruption and downtime, right? So bringing that to the minimum amount possible. If a building owner comes to me and says, "Hey, can you put these EV chargers in?" and I say, "Sure, it'll take me a week," and they're like, "I've got to shut down an area of my parking deck for a week." And then they go to somebody else and like, "Yes, I can get it done in 8 hours." So the only way to do it in 8 hours is if we prefabricate everything ahead of time. So in this situation here, we've modeled the equipment, we've modeled the conduit. We can take that, we can move it into our fabrication shop. We can make all our conduit bends. We can put our couplings on our conduits. We can fabricate the stands there for the equipment and the disconnect. And now when we go out to the job, we've just got to put our 4 stands down and then anchor our conduit. Everything's bent, couplings, all the parts and pieces are already there. I'm very confident that a 2-man team could get this done in under 8 hours. So that's, to me, that's really the true advantage from the contracting side. Where I've seen popularity rising a lot over the past few years is with general contractors, and they're using it more for the general kind of documentation purposes. And general contractors are starting to get a little more iffy about paying for different change requests and those types of things. And they want to know, hey, did you put that conduit in where you said you were? You modeled it here, so is it there? And they're starting to scan now, and they're starting to check. And when it's not there, they're gonna be asking questions, and it may start to cost money. So it's really interesting to see, different ways that contractors can use this to kind of win more jobs and save time, and then general contractors can kind of do what they've always done and try to reduce risk, right, and try to hold you to your word.
Sure, sure. And really, as far as the long-term life of a building as well, I know we're talking about existing buildings, but one of the advantages, we talk about how there's a challenge of having to, see behind walls, which is very difficult to do, or see above ceiling tiles. And that's something that that I think as a general contractor as well, if you're doing that throughout the construction process and you have a set of a documentation from before the drywall went up, then in the future you can literally go back to that point cloud and see behind the walls and know exactly where those things are, which is very, very useful.
Absolutely. And I think as the technology continues to get cheaper and the software continues to advance, I really do think we're going to start seeing more owners demanding in contract language these more as-built point cloud models where they have a model of what is behind every wall. They have a model that shows what's in the slab and where exactly it is. Because again, as we kind of talked about earlier, when you have to come back and make changes, if you have to take off drywall to see what's in the wall to see if you can put something there, that's a lot more expensive than if you can just go check a model in 10 or 15 minutes.
Yeah, absolutely. Absolutely. And then also, I mean, you get into augmented reality and you can, in real time look at your laser scan data and look at your various MEP elements. I mean, it's really impressive that, the different things that are happening there. So a great tool as far as that goes. Jason, I did want to mention one thing I thought was interesting. You said that you in your previous experience were working with a lower density to have to do faster scans. So I think the one thing to clarify, we said, that you can't have too few scans. And I think that that's true. You cannot have too few scan positions, but that's different than my first inclination working with laser scanners, which was, I'm going to crank this baby up to 11. I'm going to get it at the highest density point cloud possible. But there's a point where, if you're defining a column, whether it's got 500,000 points or 5 million points, it's really not going to give you any additional benefit. And it's just going to be a larger model, more difficult to work with. And so certainly there is a happy medium to be found there.
Absolutely. And a lot of that, depends on what you're scanning, right? And what you want to use it for. If I'm a crime scene investigator, right, and I'm using a scanner to capture a crime scene, I want every point I can get, given how much time I have. However, if I'm using it in the construction environment where I'm really just trying to coordinate around things that are there, then the point density is not as important. But then again, if I'm in manufacturing and I'm using a scanner to scan an existing object that I'm going to then mill out, again, I want every point I can get. So a lot of it is, with the point density and the scan time, a lot of that is dependent on what the use case is. But I agree. It's always true that more scans is always better.
Yeah. Yeah. And I absolutely agree that there's certainly a happy medium to be had there. And I think that there's also, what's your use case as a general contractor? There might be situations where let's say once a month you want to do a really high density scan, but then for your more construction monitoring needs, that's something you can get away with a lighter scan, and be less disruptive on the job site.
Absolutely. And when we talk about specifically using these point clouds in Revit, they get large very quickly. So when working in Revit, that's, for us in my past experience, that was the main driver for us trying not to have, too dense of point clouds, was so that the file size when working in Revit was manageable. And even not, I don't want to scare anybody off, even if you do take those super high detailed scans and maybe you have a reason for those, or maybe you just want a lot of detail, the software for working with these point clouds does let you kind of pare back that density if needed. So you can always maintain the level that you want or need.
Yeah. That's generally referred to as decimation, decimating the point cloud, and certainly very common to have, to retain that max size point cloud, but if it's something that's 120 gigabyte point cloud and you're looking to collaborate around that, might not be feasible. And so something that you could decimate down to 1/5 the number of points and work off that model, and then know that you have a denser model in your back pocket if you need to get that higher level of detail.
All right, yeah, so with this slide, this is just an example of using Evolve for prefabrication. So if anybody on there is not familiar with Evolve and what we do, we are a plugin for Revit. We also have a shop product on the cloud that you can take a look at. And so what I've done here is I've used our tools to generate this sheet automatically. All of the families that you see in there are Evolve families. And I was able to very quickly generate these prefab sheets with our bill of materials on there, our bends. So with electrical conduit, bending is definitely an issue from the model. Our bends have all of the marks and dimensions needed to make those bends without making any dimensions in the drawing. So this is just an example of a prefabrication spool drawing that certainly if you're working in a existing space, you could take advantage of 3D scanning and go and prefabricate that work.
Yeah, absolutely. And what's great is that you look at clash detection and things like that as something that's very standard in the industry, but that's also something, although in Navisworks I don't think it would work the same, but it is something that by having what's existing there, you don't need to model out every one of the components. You just have to know that what you're modeling and the scope of your project will fit in that existing environment. And so, if something that, even if it's just an electrical application, you can still get what's there and make sure that you're going to be as efficient as possible when you get on site.
Absolutely.
All right. So another question. And it sounds like with some of the folks, it's not that many that are being held back, but if there is something, what is holding you back from using advanced documentation techniques like 3D laser scanning on your projects? Is it cost implications, limited expertise within your team, limited access to equipment, or you really haven't encountered any significant challenges?
I know for us, in my experience, it was really the cost for a long time. And I think before we had even purchased one, we used a service for a period of time. That was kind of the big stopper for us. And then once the price came down, we were able to go with a company that was able to provide training. And then we had the knowledge needed to go in and do those scans.
Yep, absolutely. And again, the access to equipment, I mean, LiDAR is being incorporated in more and more things. That's how Tesla cars get around, is that they are doing real-time LiDAR assessment. You're able to put LiDAR on drones now, on airplanes. I mean, there's all sorts of applications. Even the newest Matterport is using a form of LiDAR. So yeah, look at here. This is kind of what I would expect. You know, the cost implications. I think that a lot of times, if you're interested in dabbling in the space, you end up down a path where someone's trying to sell you a an expensive scanner, which is something that certainly depending on the frequency of jobs could be worth that investment, but it's a lot to bite off right off the bat, and then also limited experience within your team. But I guess access to the equipment. So it is readily available. You guys have resources out there, which is great to hear. All right, and then next, looking at some of the deliverables here, a wide range of deliverables, whether it be your 3D models, your drawings, elements that you can export, but also here, this is a look at what you'd be working with in Autodesk Recap. So again, it's something that you can navigate a point cloud. You can kind of fly around and see an entire space. But if it's something that you want to have a more traditional virtual tour or like a Google Street View type experience, each one of these spheres is what would have been one of your scan locations. And then you can go from sphere to sphere. You can go back and forth between a point cloud interface and a photo interface. And then right within the photos themselves, you can actually take measurements. And so it's really a useful tool. And Jason, there might eventually be a workaround. Maybe there's one I'm not aware of, but what I've seen is that with Recap in particular, it's very often something that you're working on your project in Revit, but then it's great to have the Recap tool up as well for that net navigation and being able to kind of do a virtual site visit whenever you need.
Absolutely. Yeah. We primarily used Recap for really just kind of processing down or paring down the point cloud. But it is a great tool for navigating the point clouds. Kind of the analogy or the equation that I would make there is it's like your Revit model compared to going through your Revit model in Navisworks, right?
Mm-hmm.
In Navisworks, it's much, it's built for browsing a model. Revit is not. It's built for creating sheets and documentation. So it's very much like that, where Recap is meant for navigating a point cloud. And certainly if that's what you're using it for, is to look and browse through the point cloud, yeah, I would treat it like Navisworks.
Yeah, absolutely. So an extremely useful tool, and again, one that is available with the standard construction suite. And I know that there's also a free viewer. So if you have a client that maybe is not in the industry, but they want to be able to navigate and see things, there is a light version as well. So certainly a number of ways to be able to access the point cloud. Then wanted to quickly touch on other documentation technology. Jason, you and I had talked about this, specifically photogrammetry as a tool. Basically, photogrammetry, it's getting you a common result. So what it is, you're taking a large series of photos, often hundreds of photos, and then combining those. And we'll go through the workflow a little bit here. But that's often done with drones, also with handheld tools, or even with just a DSLR camera or your phone. So there's many different ways. The main advantage there is that you're able to minimize gaps that you might have with the LiDAR. No matter how many scans you have, there's certain situations where LiDAR is going to be a little limiting. I don't think that there's a 60-foot tripod for a LiDAR scanner that can be used dependably, and so combining that with drone, with point clouds generated elsewhere with drones, or with even just a handheld camera where you can put it on a selfie stick and poke it up where you need to, can certainly be helpful. Just real quickly, what we have here, this is the Tower Heritage Center in West Bend, but you can see here, this is an example where, let's see, 934 images were taken. The prominent features were then pointed out, and so you got an initial tie point cloud. Then you build out the density of those points in between to get a more dense point cloud. Those points are connected to create what's called a wireframe. And then when you fill in that wireframe, you get a more photorealistic 3D model. But for our purposes, because what the laser scanner is producing is a point cloud, generally this is the most useful step, which would be your completed point cloud with photogrammetry. And then what's important to note with photogrammetry is that although everything is relatively accurate, that means that features like, on the front door here, this is a double door, and you could see that a single door is half the width of a double door. What you're lacking is, however, scaling. And so what's really important with scaling is you need to know, is this a dollhouse or is full-size structure we're dealing with here? And so that's something that you can do with any number of methods, ground control points, infield measurements to verify. But the best way to do that, in my opinion, is to align to a point cloud that you've already collected with a laser scanner. It's something that, again, that laser scan data from here, you'd have a lot of gaps on the roof because there's no adjacent areas that you can scan from, a lot of holes here, but essentially, you'd have the entire side of the building and many even of these higher features that you can align directly to and get a much more dependable aligned deliverable there.
Absolutely. And I think kind of some of the future things that may be coming down, this is kind of what we talked about before, is, photogrammetry working together more with actual 3D laser scans. Because right now it kind of seems like the tools are there to kind of do it manually. It's almost a little bit of a workaround. But I think as things go on and technology improves, we'll start to see drones doing photogrammetry working together with laser scanning units on the ground to complete a more full picture of the job site or whatever it may be that's getting scanned.
Yeah. And really, when you look at some of these more advanced techniques and get into the AI of it all, there are platforms now where I would almost say that some of these platforms can take anything you throw at it. I've seen platforms where they can take individual 360 photos, which is a very, very affordable documentation method. You get a 360 camera for $300, $400. That'll serve you well. So that's very accessible. It can take your existing drawings and different BIM models. It can take PDFs. It can take even when you talk about construction monitoring, I think what's really neat is that there's apps where right within your phone, instead of taking 360 photos and 360 scans, if the primary area that you've done, that you've worked on is, putting in the final ceiling, that's something that you can go and just with your phone, you can document that and do a little bit more of a segmented upload as far as, kind of getting some of those progress reports in there.
Absolutely. Yeah. What, the other kind of, I guess, advanced documentation method that we used was kind of what you mentioned about the 360 cameras on the selfie stick. And for us in the VDC department or the BIM department, that was really big for us because, we're spending all this time building, we're building the building twice, right? We're building it once virtually, and then we're going out and building it in the field. But when we hand off those documents to the field, I don't know if something gets lost in translation a little bit, but there can be a breakdown in communication, and something that may happen in VDC doesn't make it back to VDC, right? So the field gets something, they're like, we can't install it this way, and so they just go ahead and install it. But us having that kind of field monitoring, like weekly or daily, somebody walks around that have a little 360 camera on their hard hat and they just walk the job. And then for us in the office to be able to see that and see the progress of the job, not only are we more aware of kind of where the progress is and kind of the things that we need to focus on, or maybe, hey, I was working in this area and they haven't even poured the footings there yet. But it let us kind of get this kind of circle of communication with the field, a lot more real-time information that we could use. Hey, maybe they didn't put that conduit over there. Should we, maybe we talk to them. Hey, why didn't you put it there? Oh, well, this or that, right? And so that way we can learn and just have better communication with the field. That was really big for us.
Yeah, absolutely. And it's such a fast, it's such a fast collection method. And something that is being more and more adopted. And even, the Faro scanner, they have a module where you can attach a 360 camera to the core unit, because you're getting a much higher resolution photo with a 360 camera as opposed to on the scanner itself. So, these technologies continue to overlap in different ways. And I think that that's really what's going to be interesting, and where there's going to be a lot of innovation in this space. All right. What are you most excited about when it comes to MEP design? We can do this a little bit quicker. We're looking at, hey, just wide-scale BIM adoption, more people using BIM, the better. But then there's 3D laser scanning, not laser scanning, laser scanning. And then there's some modular MEP solutions that are being talked about, really expanding the prefabrication model, and then artificial intelligence, and who knows all the applications that could be worked in with that.
So mine may not be a popular one, but it's wide scale BIM adoption, and maybe not in the sense that most people might be thinking, but it's as a contractor, we would get we're like the fourth or fifth people to get a model, right? So when it comes to an engineer and architect's documents, they create the documents from a model, but they don't stamp the model. And so we're working from paper, but we have this model that we're technically allowed to use, but they've got this giant disclaimer about that it doesn't mean anything. So I would really, really love to see, wide scale BIM adoption on kind of the more, whether it be regulatory or the kind of planning authorities, to kind of require more stringent BIM, models, because it is already happening. We're already using those models. So it'd be nice to see a little more commitment from farther upstream to that, to help us make that MEP design a little more streamlined.
Yeah, absolutely. And yeah, it looks like 3D laser scanning and related tech. Obviously we're big advocates of that, and so that is a good amount of the respondents here. Also artificial intelligence and all the things that entails. But I agree. I mean, wide scale BIM adoption, it's something that, working with one of our clients here in Milwaukee, there is a situation where they've now really adopted BIM as part of their practices. And what they tell me is that they might have situations where BIM coordination is optional to participate in, but they've been on the back end of this design process enough as an electrical contractor to know that they're going to avoid a lot of headaches if they participate in those meetings and they get involved and they are communicating. And so I think that it's something that once you kind of drink the BIM Kool-Aid, it is something that the more people are using, the more useful it'll be.
Absolutely. Yeah. I remember talking to a customer of ours recently, actually, and where they're at, they're kind of more farther out from any large city. But he was telling me no jobs ever get BIMmed out there. They don't do any coordination. And he said he would go to the different trades and try to convince them to do at least some level of coordination. And I think that just kind of speaks to, how important and how much time and money you save when you do plan ahead, right? If you don't plan ahead, you plan for failure.
Yep.
So I think BIM is really a great embodiment of that.
Absolutely. All right, and then perfect timing. We'll stick around for a couple extra minutes here, but I want to thank you guys for having us here today. And I want to hear some of the questions. Hopefully there are a few that you guys might have. So thanks for having us, Jason. Thanks for being with us here today. But I guess Marina, are you the one that throw them in the chats if you have any questions or any experiences that you've had, or maybe something that you feel like we haven't really covered that you think that your peers would really benefit from. And I guess Jason, anything you think we missed?
I'm trying to think. I I think we covered it pretty well. I guess for somebody shopping around, right, for a laser scanner, right? What should they be looking for? Is it on the software? Is it like the ease of use of the software? Is it just the lowest minimum price? You know, what are the things to look for when shopping for a laser scanner?
Mhm. Yeah, and I think that you know, certainly price is a consideration. Also, but also the accessibility of the data. You know, that's something where yes, Matterport is now incorporating LiDAR, but it's something that point cloud is not that accessible, and being able to access that raw point cloud is very important. And also the the overall quality of the scans is certainly something that with a more budget unit you're getting a little bit more of a budget result. So you know, that's certainly a consideration as well. But also, you know, our company, we don't sell laser scanners. There's a great resale market, so by all means, it's something that you can really look into. Jason, we do have a couple questions here. First, how difficult is it to model from point cloud data?
Speaking from it's kind of difficult. It's certainly not user friendly. You can certainly do it. There you really have kind of two options. One is just to work with the point cloud directly. And what that ends up coming down to is a lot of very tight, you know, short section views, 3D views where you're kind of moving it around and looking. It's certainly possible. And that's another reason why you know, the performance of that point cloud in the model is very important. To be able to kind of have that smoothness so that your brain kind of interprets it as a single object. The other option is this takes a little more time, but especially if you're going to use a point cloud of an existing structure, is go ahead and model some of those elements from the point cloud. Model the floors, model the roofs, model the columns, model the walls.
Mm-hmm.
That will help you a ton of just having the actual 3D elements in your model, so you're not relying on those points. Because as you start to zoom in on some of those things, your point cloud starts to become more of a point mesh.
Right. And also, I mean, there's some things you can do to make it easier with a point cloud. You know, you can clean up a point cloud, so you're gonna capture a lot of things that you don't need. You know, with things like reflections or mirrors, you're gonna get some points that that the data isn't accurate, so you can clean that up a little bit. You can also segment your data, so you can identify your different views before you import it to make it a little bit easier. So certainly different things you can do to make it more user friendly. Certainly something that maybe down the line, that's something that we can explore discussing further is all the different ways that you can work through those challenges. And then Maureen, I'm not sure if you're usually asking these questions, but there's another one we have here. Can you run clash detection between a design model and a point cloud file?
On that one, I would say it depends. I know Autodesk has cloud clash detection now. I'm not sure that you would be able to upload a point cloud file to that. What I do know is you can get those point clouds into Navisworks, and you can clash anything in Navisworks. So I would say yes. I mean, yes, you can do it. It just might depend on how you go about it.
Yeah, and I could see that being an AI and an AI innovation as well is something that very quickly will give you some clash detection capability as quickly as possible. And then certainly with the different components, if you're doing a series of laser scans and you're using some type of augmented reality or overlaying your BIM model, I mean something visually you can kind of see, hey, is this being aligned as was intended. So great. Well, I mean, Jason, I know you and I were saying that we could talk about this for another hour. But Marina, I think you like to keep these things a little bit tighter. So again, want to thank everyone for having us. Marina, thank you for having us. Really enjoy the ongoing partnership we have with Evolve.
Yep. Thanks so much, Ross, for hosting this today, and Jason as well. This was a great conversation. And thank you to everyone who attended. Please make sure to follow Evolve and BIMTM on social media for more webinars and events like this. And as a reminder, this webinar has been recorded, and we'll send the recording in an email to all registrants. Thanks so much and have a nice day.